A very good morning to all. Today, myself, Abirami, working as an assistant professor in Christian College of Engineering and Technology, Oddanchatram. Now I am going to deliver a small lecture about the elements of railway tracks. Before going for the elements, basically we have to bring out the introduction about what are the modes of transport are available. So in day-to-day life, we are utilizing four modes of transport. One is highway, railway, airways and waterways. So among these four modes of transport, which transport provides as a feasible one to the users? So as a human being, as a public, in what factors we will consider while choosing a mode of transport? So among these four modes of transport, by considering a safety, economy and comfortable journey, we will prefer a railway mode of transport. So in railway, in how the tracks are getting assembled. So what is the technical description behind that? So we are going to see about the elements present in the railway tracks. So what are the elements are presenting in the railway tracks means ballast, shoulder, sleepers, embankment and subgrade formation. So these are the elements are presenting in the formation for making out the railway track for the smooth moving of train on it. So track formation. So before going for the track construction, we have to consider from the ground level. From the ground level only we will starting out the construction of an entire track formation. So the track formation is constructed in the top surface by means of providing an embankment on both sides. So both sides, here in this picture you will see an embankment consists of both sides with a slope. Usually we will provide a slope of 2:1 for making out the track formation. So requirements. So what are the requirements we are need in providing the permanent way? So all the elements, what I am going to say in the first factors is railway, sleeper, ballast, fixtures and fastenings. These are considered as a permanent way. So by constructing a suitable permanent way, what are the requirements are needed? So the gauge distance should be uniform. So the gauge distance is nothing but the railway ends, between the two ends of the track, the inner part of the distance is the gauge distance. So two rails are forming along the track. The distance between the two inner distance is called as the gauge distance. So then alignment should be correct. So alignment means the alignment should be straight. So as far as the horizontal and vertical alignment, here in our railway we will consider the important factor of forming a super elevation. Super elevation is nothing but we have to see when the rise and fall of the gradient is coming along the track by considering the survey. By choosing of the survey, we will go for the alignment work. So that alignment work should be free from any irregularities. And then radius and super elevation. So when the turning, in usual way, the track is not always goes in a straight formation. So besides we will switch on to the curvical nature, that means curvature. So in that curvature, how much of radius we have to give? So based on the available location and space provided on the ground surface, we will choose. And the drainage system. So the drainage is nothing but in train the wastewater will fall out on the ground. So in that we have to provide a proper drainage in order to free fall of water inside the ground without any stagnation. And then we have to go for a easy renewal and replacement. So whenever any fault occurred on the track, that means in the elements, we have to go for a removal or replacement, or we can go for a remedial work. The structure should be strong, low and initial cost. So when compared to other mode of transport, we are track formation is the easiest and economical one. We are choosing the permanent way requirements. So what are the permanent way materials are behind that? Rails, concrete sleepers, fastenings, switches and crossings. So these four are the major component for making a permanent way. So rails is nothing but in normal way when you are as a public, when we are viewing the track, the two steel sections are passing on the ground surface. It is called as the rail. So the rail is nothing but it is made up of a steel section on either sides. So it goes beyond according to the length of the track. So it provides the function for the smooth operation. So when the trains are moving on the rail surface only, so the entire vibrations what are all coming due to the load on the occupants or any other moving loads or impact or vibration, that will be transformed to the rails, and then rails to the ballast to the sleepers to the foundation. The load transformation will be occurring. So mainly we are considering the rails in order to withstand the bearing stresses and to prevent the thermal stresses also. It have to withstand the vertical loads on the track. So types of rail. So we can construct the rails in the form of three types: double-headed rails, flat-footed rails and bull-headed rails. Double-headed rails means the rail is mostly constructed by means of a track distance, gauge distance. By considering the gauge distance, we will choose out the rolled steel section. So the steel section will be consist of head and foot. Top surface is called as the head and bottom surface is called as the foot. So here both the top, that means head and foot surface will of same dimensions in order to withstand the impact loads and vibrations which are all occurring on the train, which are all coming from the train. So here in the double-headed rail, the dimensions for making the double-headed rail for head and foot will be of same. So it is the diagram shows the double-headed rail. Here the head and foot are of same width and same thickness it follows. And flat-footed rails. So flat-footed rail is nothing but in the foot section. In previous itself I have said in rail section consists of a rolled steel I section, and the top portion is called as the head and bottom portion is called as the foot. In foot, the foot surface will be a flatted one. When compared to the double-headed rails, both the top and head are of same dimension. But here in flat-footed rails, the bottom surface is of a flatted one in order to withstand the loads to the sleepers and sleepers to the ballast, to withstand the lateral forces and the vertical stiffness, etc. So here when we are going for flat-footed rails, in points and crossings, we are providing a easy and comfortable moving out without any jerking when we are giving for a flat-footed rails. So it is a diagrammatic representation of flat-footed rails. See, in the flat, that means the bottom surface is called as the foot. The foot surface is flattened one. So in this way, the rails I section will be provided as a flat-footed one rail. And bull-headed rail. So in bull-headed rail, when compared to the heads of double-headed and flat-footed, bull-headed rail head is more. That means the dimension will be more for head. So it is a bull-headed rail. By the name itself we can say bull-headed rail. So it is a diagrammatic representation. See, in the head the dimension is very heavy on the head surface. So it is called as the bull-headed rail. So the rail is designated by means of its weight per length. We can denote the rail, that means the unit of rail is designated by weight per unit length. So it mostly by considering the maximum load. What are the maximum axial load coming from the train, and permissible speed, depth of the ballast, spacing of sleepers, and gauge distance of the track. We have to design the rail section. By considering these 5 factors, we have to design the rail sections. So the rail section mostly available in the form of 60 kg and 52 kg in recent days. So it is designated by the unit as 60 kg per meter length. Rail length. So in rail length, so we have to consider the rail length by means of giving a lesser number of joints. So in joints, when you are going for the rail is connected by means of joints. So in the rail length, we have to give a less number of joints, because of due to construction and maintenance, we are providing less number of joints in the rail length. So by considering the following factors, the rail length have to be provided. So it is if we are providing a longer rails, means it is difficult to transport due to heavier weight of steel section. If the rail length is longer, means it is difficult to transport, and the manufacturing of longer rail is also a difficult one, and it is a wide expansion joint. Difficulties, expansion joints when we are providing for longer length will be difficult, and then it can't able to withstand the internal stresses when you are going for long rail length. And then it is a gauge. See in the diagram, the 2 rail sections are going beyond. So inner distance between these 2 rails is called as the gauge distance. So it is the diagrammatic representation of gauge. When we are seeing this diagram, we can measure the inner distance between the 2 rails. It is called as the gauge distance. So here also the types of gauges are also there: broad gauge, meter gauge, and narrow gauge. So in prehistoric days, they are using a meter gauge, and then they are going for a narrow gauge. Now at present we are using a meter gauge in India. So these are the elements. First of all, how we are making the railway track is the base formation. When we are coming up from the ground level, we are looking for a formation, and then ballast sleepers, and then rails, and then joints and fastenings. That means fixtures and fastenings. Formation. So the formation is nothing but we have to how much amount of load is coming from the train, and by considering the other elements like ballast sleepers, we have to lay the formation from the ground level. And then functions of formation. So we have to provide the formation in the form of a smooth and uniform bed on the surface. So it can be able to resist the load transmitted from the moving loads. Here the moving loads, we are talking about the train loads. So you have to provide a drainage facility, proper drainage facility. By means of drainage facilities only, the wastewater coming out from the train will be directly goes beyond the formation. It provides you have to provide stability to the crack. Design aspect. So how we have to provide the width, height, and side slopes. So by considering the width, we have to see the number of tracks to be laid. So how many number of tracks are going to be laid? We have to consider the width. Gauge of the track. We have to consider the gauge of the track. And then width of the ballast. For how much width we are providing the ballast layer. And then width of the drains. And when going for the height, from the height of the train to the depth of the formation, till the formation, how much height is there? It depends on the topography and alignment of the surface. And then side slopes. Side slope is nothing but we have to usually provide a 2:1 slide slopes on either sides in order to make a stability to the track. 2:1 ratio, we are providing the embankment on both sides by considering the shear strength of the soil and the angle of repose, etc. And then sleepers. Sleepers is nothing but we are in the track itself. When we are seeing, there is a horizontal platform, horizontal flat surface of concrete sleepers are laying nowadays. That horizontal arrangement of concrete specimens on the track is called as the sleepers. So how the functions are providing for us to the sleepers for the rails means, it holds the rails to the correct gauge. The sleepers hold the rails in order to bring up to the correct alignment, and then it gives a firm support to the rails. So it distributes the loads evenly to the sleeper area, and then sleeper acts as an elastic medium, because the huge amount of heavy amount of load is coming, vertical load is coming from the train. That entire load area is evenly transmitted to the sleeper surface, and then it maintains the alignment of the track. It holds the alignment, and also it provides an insulation for electrified tracks. Classification of sleepers. So sleepers are classified into wooden sleepers, steel sleepers, cast iron sleepers, and concrete sleepers. So wooden sleepers is more, in previous years they have used wooden sleepers. So nowadays, due to the passage of time, due to the impact occurring due to the train load, these wooden sleepers have been overcome by the concrete sleepers. So the advantages for wooden sleepers will be, it is easy to manufacture, and it is more useful to withstand the heavy loads and high speeds. It is easy to handle, and then it is suitable for soft formation. If the formation level of the ground is soft, means the wooden sleepers are preferable. So it can be able to absorb more shock and vibration. And then disadvantages. So it is being a wooden sleeper, it has the disadvantages of vermin attack. That means termites are attacked in the wooden sleepers, and it is susceptible to fire. It is easily attacked by fire also. Being a wooden surface, it is easily attacked by the fire. So its maintenance cost is also highest. So it has the lifespan of very short span, 12 to 15 years. It have to be able to work.